Hi everyone, this is going to be your note for 7.4, working with rational exponents. So a rational number is a number that can be expressed as the quotient of two integers, or like a fraction, where the denominator is 0. So rational exponents are simply fractional exponents, or exponent that's just a fraction, like 2 to the power of 1 over 4. So we've seen this in other grades, but now we're going to be examining them a little bit more. So to kind of do a warm-up, I'm going to put this number here to get you started as well. I want you to pause the video, try and complete the table using any patterns that you can kind of figure out. You can read this for help, and then when you're done, unpause the video, and we'll go from there. Alright, so you might have said that the square root of this is 2. And you might have noticed that our powers here, power of 4, we're going to have 4 to the power of something, and then 4 to the power of something here, which we're going to figure out. We don't know what this is, and we don't know what that is right now, but we're going to figure them out. So we notice that if we do the square root of 16, that is going to be 4. And noticing your pattern, this is like having an exponent of 1, because 4 to the power of 2 is 16, but that's the same as the square root of 256. And same thing happening here. So here, 4 to the power of 8 would be this. And if you wanted to figure out this column over here, you would get this squared, and then you would get this number here. Sorry, it's a large number. 4294967 So if I took the square root of that number, and I apologize for this square root sign, it's not the nicest, then I get this number again. So what are we going to have for our power for this number now? Well, I know if I had 4 to the power of 0, that would just equal 1, so that does not equal 2. So what's a number that's between 0 and 1 that I could use to get this? So what if I typed on my calculator 4 to the power of 0.5? You know, halfway between those two numbers. And if I did that, I'm going to get 2. So our exponent can be 0.5 or half. Sorry, this got cut off a little bit. I'm just going to move it over. Just wrote the number 2 here. So 4 to the power of half is going to give me 2. So from the table, we see that the square root of 4 is equal to 2, but 2 is also equal to 4 to the power of 1 over 2. Therefore, a rational exponent of 1 over 2, or half, is equivalent to a square root. So we can rewrite this, these square roots as powers with a rational exponent. So square root of 25 we know is 5, but I can also write it as 25 to the power of 1 over 2. Same with b. Square root of 49 can be rewritten as 49 to the power of 1 over 2. We can rewrite these as square roots, knowing that 36 to the power of half is going to be the square root of 36 like this, and this will become this. So don't worry too much about this another way. We just want to know that we can rewrite this as 4 as power of half. And what I want you to know is, why are we learning this kind of stuff? Well, we're going to encounter things with algebra that might get a bit more complicated, so we have to understand that these mean the same thing, and that they're interchangeable. So as an example, let's say I have the square root of 4 times the square root of 4. What is that going to be equal to? Well, you would normally do like just 2 times 2, which is equal to 4. I could choose different numbers for these though, but I'm just going to choose 4 for now, just to show how we can use this. So I could also rewrite this as square root of 4. Well, this is the same thing multiplied by itself, right? So this is square root of 4 to the power of 2, because it's this multiplied by itself. Now if I change this square root to a fraction, I get 4 to the power of half to the power of 2. And using our exponent laws, I would multiply these together, and I would get 4 to the power of 2 over 2, which is the same as 4 to the power of 1, which is equal to 4. So that's one other way we could show this, how to solve for this. Another way we could show it is by doing, by changing both of these to fractions. So what if I had 4 to the power of half times 4 to the power of half. With our exponent laws, I would add these exponents together because they have the same base, which is if I add my fractions, I only add the numerators. I get 4 to the power of 2 over 2, which is 4 to the power of 1, which is also equal to 4. So just other ways that we can show and solve some equations with algebra. So yeah, this can just be written as what we saw. It can be 4 to the power of half, like that. So let's extend this idea a little bit. We know that 2 to the power of 3 is equal to 8. So we can actually rewrite this as a cube root of 8 is equal to 2. And if you're wondering, well, how do I do a cube root? It depends on your calculator. So some calculators actually have a, let me see if I can zoom in even more. Is it possible? Without it being blurry, turn off the light. What if I press this focus button? Oh, there we go. So if here's a cube root button right here. And for me to access that, I would do the second function and then this button because it's over it. It might be a different spot on your calculator depending on the calculator. You'll also notice that this is x square root. So if I wanted a different number besides 3 or 2 for this button, because this is a square root sign, if I wanted some other number, 4 or 8 or 9 or something, I would put the number and then do the second function, this button, to get that. So I'll come back to this in a second. But let's get back to our example. So if I want to check this on my calculator, I can do this second function, cube root. You see the 3 with the square root sign there of 8 is equal to 2. If I wanted to use this button here with any number, I would just put the number first, cube root, and then I press this root button, and then it's 3, and then x is 3 in this case, so cube root in this case of 8 is equal to 2. So this number can be any number, which we'll see in a second. So I can write this as, if this is like, we said before that 4, 1 over 2 is equal to the square root of 4, and this is technically a 2 here. So if this is a cube root with a 3 here, and this is the exponent here, I can actually write this as a fraction as well as 1 over 3. So the rational exponent of 1 over 3 is equivalent to a cubed root. And it doesn't matter the fraction actually. If I have 4 to the power of 1 over 4, that's the same as a fourth root. If I have 5 to the power of 1 over 8, that's going to be an eighth root of a number. Oop, I'm just going to write 8. Like that. So this is a pattern that's consistent for all of our square roots as a rational function. So now in our calculator, let's say I wanted to find the eighth root of 5. What could I do? I could do 5 to the power of, and my power button is here, 1 over 8. And I would get 1.2228, blah, 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 blah. Or I could do this now with my root sign. 8 is the number I want for the root. And then I'm going to do 8th root here, so that's where I see x is equal to 8. If I did it for 5, I would get the exact same number. So again, these mean the same thing. So as some examples, we can rewrite each with a rational exponent. This is a cube root. This is the same as 20 to the power of 1 over 3. Again, if you want to pause the video and try these first and then check your answer with me, you can do that too. Here I would have 64 to the power of 1 over 3. And as we saw before, I'm going to have 1 over 5 because this is the fifth root, so 1 over 5. To rewrite each of these as a root, I would have cube root of 27 here. 54 to the power of 1 over 5, this is the 5 here, this would be a fifth root. And for this one, this is 9 to the power of 1 over 8. This is the same as an eighth root, like that. And then we just put this in our calculator. Again, we're just being able to solve these in different ways now. So here's the official rules for how we have rational exponents. So this looks complicated. Let's just break down what it means. So in general, x 1 over n is equal to the square root of nx, which just means if this is a fraction and the numerator is 1, and whatever the denominator is, any number n, is going to be the nth root for that base, so nth root of x in this case. So n has to be greater than 1, so we don't have any negatives here, and n is any natural number. So for a natural number, you just have to know we just mean a non-negative number. So it has to be a positive number, which also fits the n has to be greater than 1. So our exponent is always going to be a positive fraction. Well, what if it's a negative fraction? Well, that's later on, much later on. So you might be thinking, well, what if the numerator is not 1? What if it's like 2 or 3? Well, I'm going to zoom in on this part of the definition, where we, maybe even more because it's really small. So we have x is equal to m divided by n, which if we were to split this up using our exponent laws, this is the same as x to the power of 1 over n, because an exponent to another exponent, I would multiply these, which I would get this. And this is actually the same as me doing an nth root of x, and this is on the outside. And then alternatively, this is also the same as I can also move this exponent here inside to the x. So just notice where the fraction is. The denominator is always going to be what the root is, and the numerator is what the x is going to be to the power of 2, or what the whole thing is going to be to the power of 2. So let's go over some examples, because I think that'll make it a bit more clear. So this one first, we have a fifth root is equal to 52. How can I rewrite this as a power? This would be 52 to the power of 1 over 5. And this one's going to be testing our our new definition. Well, if I have cube root and then exponent here of 4. Remember, this is the same as, I could rewrite it like this if I wanted to. Because remember, according to this definition, the exponent m here can be on the inside or the outside, with brackets, or if the brackets are gone, this would be with the x. And this would also be the same as 2 to the power of 4 over 3. Because the root here, cube root, is the denominator, and the power, the exponent here, is the numerator. So now we're actually going to evaluate each of these expressions without using a calculator. Sorry, just to go back before I move on to this, just so you know, I did mention here that m and n here are both integers, and the base x cannot be equal to 0. So these are the restrictions we have on our second part of our definition here, is that m and n are both integers, and the base x cannot be equal to 0. Okay, so for example 2 here, we're not going to use a calculator. Will I do that to you? In reality, no, you would be able to use a calculator, but we can use this using our exponent laws and what we know about exponents. So to solve 64 to the power of 1 over 3. Well, 64 looks very familiar. If I know my multiplications, that's the same as 8 times 8, which is the same as 8 to the power of 2. So I can rewrite this as 8 to the power of 2 times 1 over 3. Then using my exponent laws, I can multiply these. I get 8 to the power of 2 over 3. I'm just going to make this bigger. So yeah, this is 8 to the power of 2 over 3. This is an exponent. So according to my definition, the denominator is going to be the root. So it's going to be a cube root of 8. And the 2 can be on the inside with the 8, or it can be on the outside here. So I'm going to move it on the outside. I'm going to do that because I can know the cube root of 8 is actually 2, because 2 times 2 times 2 is equal to 2 times 2 is 4, 4 times 2 is 8. So cube root of 8 is 2 to the power of 2, which is equal to 4. So I could just type this on a calculator, but I can use my algebra to figure it out on my own. For B, it got cut off, so go straight to C. That's why there's a blank here. I'm very sorry for that. Sorry, I just wanted to zoom in a bit. That's why I had to recut that part of the video. So if I have half as exponent here and a fraction as the base, well, remember, if I have an exponent applied to a base fraction, I have to apply the exponent to the top part and to the bottom part of the fraction. So I'm going to apply this half to the top and the bottom of this fraction. So 9 to the power of half over 25 to the power of half. And we said that this can be this half as an exponent can be written as a square root over square root of 25. And then by doing that, square root of 9 is 3. Square root of 25 is, I'm just going to remove this here, is 5. So my answer is 3 over 5. And for D, it says 4 to the power of 3 over 2. So again, I have the 2 as my denominator. So that's going to be my root 4 to the power of 3. Square root of 4 is 2 to the power of 3, which we said from over here in part A over here. 2 to the power of 3 is equal to 8. So remember, the denominator became what the root was, and the numerator became the power on the outside. So that's how we do questions like that without a calculator. So this last part we can use a calculator for, because we're going to get a decimal here. So I can use my calculator to show this two different ways. Again, I could just do 7 to the power of, try not to get that reflection there, a lot of reflections. 7 to the power of 1 over 2, which give me 2.64, or let's just go to 2.65, let's say. 2.65, or I could find the square root of 7, which would just be square root of 7 is equal to 2.65. So they get the same thing. So here's the homework you can try, and thanks for your time.